Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Little Region Sum CC, or Chaos Construction, by P.S. Nin. And here are the rules. We have Sudoku rules, which means fill in the digits 1 through 9 in each row, column, and column of the grid so that no digit is repeated within the same row or column. We also have chaos construction, where we need to divide the grid into 9 distinct regions, each consisting of 9 orthogonally connected cells. Each region must contain the digits 1 through 9 without repetition. The borders of these regions must align when the grid is rotated 90 degrees. That's interesting. Okay, that's a new one. So you have typical chaos construction rules where you need to divide the grid into 9 distinct regions. But the borders of the regions must align when the grid is rotated 90 degrees. So that means it must be rotation. So say we had this region here. Is that one? 1, 2, 3, 4, 5. Yeah. So this is a valid region. Then that would mean if you rotate it 90 degrees, this would have to be a region also. Right? Because if you rotate the grid 90 degrees, then it would have to match exactly this pattern. Obviously, this could work. So then you could have something like that, and then that, then that, then that. Okay, obviously it wouldn't completely work, but that's interesting though. Um, 4. Hold up. No, that's wrong. Okay, so this wouldn't work. 1, 2, 3, 4, 5, 6, 7, 8. Huh. This would work though. I was actually creating it incorrectly. So this would actually work. Right? So this would be a valid example of rotation of 90-degree rotational symmetry. If you rotated the grid 90 degrees, this would work. But the problem was my original one was something like that. Could that work? Probably not. So the original one would be, if this were 90 degrees, it'd be that. Yeah, and therefore this would break. Because this would have a region which would be either 11 cells or it'd have 2 regions which would each add up to 11 cells, which obviously doesn't work. So you have to keep that in mind, the 90 degrees rotational symmetry. If you rotate it 90 degrees, it must be exactly this. The region borders must be exactly the same. Huh. And these are orthogonally connected regions, so therefore that means you can go from any cell in that region to any other cell in the region, staying within that region just by going through edges. So this is a valid region. This is not, because to get from this cell to any other cell in the region, you would either have to go outside the region or cross by a corner, which is not allowed. This is also not a valid region because even though they can connect to each other through edges, they can't connect to the other cells in the region through edges while staying within the region. So that's chaos construction. And we have a special twist where, remember, we have the 90-degree symmetry, where if you rotate the grid 90 degrees either direction, you will have exactly the same region borders. Interesting. We have Little Killer, where outside the grid, arrows are accompanied by numbers. These numbers represent the sum of the digits in the direction the arrows are pointing. So these digits must add up to 27. These digits must add up to 27. These digits must add up to 40. And he's helpfully lined up each diagonal, which has a little killer. That's actually very helpful. I appreciate that as a for if puzzle setters did that for little killer clues. That's pretty nice. These numbers represent the sum of the digits, in the digits direction the arrows are pointing. Ah, okay, that's the reason why he has the lines. It's because these are region sum lines. So as you move along the path of an arrow, the sum of the digits within the region must remain constant each time you cross a region border. So these are region sum lines, essentially. And, for example, if this were to be one region here, let's remove this region here, and this were a region here, these must sum up to what these digits sum up to. Okay. And then finally we have ratio dots, where black dots connect the two digits with a 1:2 ratio. And these digits must not be in the same region. So these digits are in separate regions. And if, say, this was a 4, this would have to be a 2 or an 8 to maintain the 1:2 ratio between them. Those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so the region borders... Oops, this is center only, reading on edge. This is a border. If you rotate it 90 degrees, that border must be maintained. So that would be 90 degrees from there is there, 90 degrees from there is there. This is also a region border. If you rotate 90 degrees, that would be third here, so it would be here. If you rotate 90 degrees here, so 3 by 3 and then across there, 3 by 3 and then across here. Right, if you rotate 90 degrees that way, it would be across there. Okay, so this is also a region border. If you rotate 90 degrees, it would be here. If you rotate 90 degrees this way, it would be there. If you rotate 90 degrees that way, it would be here. So this we're going to mark as dark. We guarantee this has to be dark. We're going to mark this as medium gray. We're going to make this light. This is green. We don't actually know if this is medium gray. So this is green. We're going to make this red, and this has to be red, and this is yellow. So this is blue, blue, and we're going to make this orange. Okay. Interesting. This adds up to 21. Across this line. How many regions does it have to go through? It could go through 7. That's really unlikely. It could go through 7 or 3. Actually, let's go to the 27. The 27s have to go through 3 cells. They're 5 at length at most, so it can never be 9. And the only divisible way that you have a region sum, where each region has the same sum, is if they're all 9. So therefore, there are 2 9s along this region sum line. So this must go across 3 regions. Same with this. Same with this. This is 27 also. So this must also, well, we don't know if it, this has the same, that it goes through 3 regions here, though. We just don't know how the regions are divided up. This is 40. It could be 2 regions, not 3 regions. It could be 4 regions, 5, no 6, no 7. And 8 regions is also possible, but no, actually 8 is not possible because it's 7 in length. This could technically be 7 regions. Very unlikely, but possible. These digits are in a 1 to 2 ratio with each other. So it's 1, 2, 3, 4, 6, 8. Same here. 1, 2, 3, 4, 6, 8. Same with these digits here. 1, 2, 3, 4, 6, 8. Say we had the single digits on the outside. I don't think that's possible. Right? Then that would force this to be 9 and 9. And this would also be 9 and 9. And we'd have a contradiction there. So you cannot have single digit. You can't even have single digits both on the inside. So if we have single digits both on the outside and single digits on the inside, you'd have the same problem. This would be 9 and 9, and this would be 9 and 9. Right? Because it has to be rotationally symmetrical, or 90 degrees. So these would be, if these are the singletons in the original, in this line, these must be the singletons there. So it must be one of these is a singleton and one of these is singleton, or this and this is singleton. Wait, that doesn't work. It can't be singleton, singleton here, because then all 4 would be singleton. So it must be 2. So this must be a border here. So it's either these 2 are the same, or these 2 are the same. Right? Yeah. So either these 2 are the same border, or these 2 are the same border. Huh. Either way, we know these are different regions. But what does that tell us? I don't really know. Yeah, that doesn't help. So, can this actually be 7? That is a good question. If it's 3, you're guaranteed that these are all the same region. This is all the same region. But it could actually be 7, though. This is either 2 regions, or it's 4 or 5. 2, 4, or 5 regions. What does that mean, though, since this is 27? Doesn't that mean... Okay, so either this is 9 and 9. That's 9 and 9. That would be 9 or 9. No. This would be 9 or 9. And then we don't have any information about this diagonal. So if that were 9 and 9, these are two separate regions. Huh. Say it's 3. It would have to be evenly divided into 3 regions, 3 cells each then. Because you could only have 3 cells add up to 7. You can never have 4 cells add up to 7. If you try to have 4 cells, that would add up to 10 at minimum if they're in the same region. So 3 is the max, and since there are 3 regions each, you have to have 9, all of them being in the same region. So this would then be blue, blue. This would be light, light. This would be all the same region. So then this would be dark, dark here. This would be guaranteed red, red. This would all be the same region as pink. Which means all of these would be the same region. Okay. And this would have to be 1, 2, and 4. Guaranteed. Ah, that's interesting. Either way, so say you had 7 regions, each adding up to 3. If you had 7 regions, each adding up to 3, this is then 1, 2, or 3 at most here. So this is basically along this line, it's basically 1 through 4, guaranteed. Huh. That's interesting. So it could be 1, 2, 4 as a triplet, or, some combination of 1 and 2, or 3. Interesting. This center one could not be part of another region if it were divided into 7. Because if it were part of that region, it would also have to be part of that region to be 90 degrees symmetrical that way and then that way. So this would be 3, guaranteed here. There would be a pair of 1 and 2s somewhere, and then the rest would be 3s. So because of that, this would not be part of any of these cells. I mean, that's possible. You could have something like this, right? In fact, it would kind of have to be that way, right? I guess it wouldn't necessarily... yes, it would have to be that way. So if this is 7, it would have to be this as the center cell. Right? Because you're blocked on this end, you're blocked on this end. You don't actually have to do that. You do have to go out here. But say you went something like that. This is possible too, actually. I didn't think about that. Something like this, right? No, that's not 90 degree rotationally. No, that's not possible. Right, it's 90 degree, not 180. 180, that would work. But 90, yeah, you actually are stuck this way. It has to be this. Because if you rotate it 90 degrees, it has to be the same. And that only works if that's the case there. Okay. Um, hmm. That seems fine. So what if it's just 3 regions? So if it's 3 regions, obviously these are the same region. This is the same region. This is the same region. This has to be the same region. It must be 90 degrees symmetrically rotatable. To connect, again, then this would have to be this region. So these are always the same region is the point, I guess. So we know then this is always the same region. We guarantee that. It's just that if it's a square or it's a cross. Huh. Interesting. Um... Ah, it cannot be a cross. If it's a cross, then this is blocked. This is going to be the same value as that, and they can't be the same region. So it cannot be a cross. Therefore, it has to be a square. This is 8 because it's that could be 4. It's just that you can't have the line every time you get the sum of the digits within the same region must be constant each time you cross a region border. So this would have to be the same value as that, which is not possible. So this is the boundary here. We know that these go this way. Then the green has to go this way because it has no other place to go. So does the gray, medium gray. So does the orange, and so does the yellow. So this is boundary, this is boundary, this is boundary, this is boundary. This has to be a 1, 2, 4 triplet. So this is a 1, 2, 4 triplet, which means this is 3, 5, 6, 7, 8, 9. This cannot be 4. It has to be 5 digits. So this is 8. Sorry, 5 regions. Because a single digit can never be 10. This digit is 1, 2, 4. That's all cannot be 3 and 6 then. This is 1, 2, 4, and 8 as a ratio. Say this was the same region and not red. That would force red to be here, yellow to be here. And this would be a region by itself, probably green. Actually, it would have to be green. So this would then be light. This would have to be green. This would be dark. That would be medium. This would be blue. And this would be orange. We're guaranteed that this blue region is at least 2. Could be 3. We don't know. That means this is green. So this would be yellow. This would be medium, and this would be orange. So that seems okay-ish. We have 1, 2, 3, 4, 5, 6. Can this ever be yellow? No. Because if this is yellow, 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess, actually, red could go that way and red could go that way. That's possible, then. So that looks fine. This cannot be both reds here, though, because that would block yellow. So if this is the same, this is yellow, this then must form a red here. That forces this to be green. This would be medium. This would be orange. So this would be blue, light, dark. This would have to be a different region. So this would have to be orange, essentially. This would be green. This would be yellow. This would be medium. This would have to be yellow to connect, orange to connect, green to connect, and gray, medium. So both of these look fine. Either way, though, red has to have a singleton, and it has to be a 9. The corner essentially has to have a singleton on this line, and it must be 9. We just don't know which. So this can never be 9. It's 3, 5, 6, 7, 8. Same with this. So say we went blue that way. If blue's that way, this is a separate region. It's probably yellow. It could be red. Huh. That doesn't tell us too much, unfortunately. This can never be yellow, I don't think, right? Say this is yellow. This is also yellow, right? Yeah, I guess it... What happens if this... So obviously both of these can't be red. If they were both red, There's just no place for yellow to be, right? So this has to be yellow. Yet one of these is yellow. If red ever goes to here, it blocks off yellow. If red goes that way, it blocks off yellow. So this has to be yellow, which means this must be orange, which means this must be medium gray. That's green. Can this ever be blue and blue? I don't think so, right? If it's three blues, essentially. Yeah. It can't, if it's three blues here, you need at least 2 digits to add up to 9. 2 digits from 1 through 3 to add up to 9. I guess it could be 3. No, can't be. If this is 1, I guess it could be 3 and 5. Okay, so let's say this was blue and blue. We know there's a guaranteed blue in one of these, at least. And can it be 3 is the question. So I guess it could be 3 and 5 here. And then this is 1. So this would be 1. But that's weird. You have to connect somehow. You can only have a singleton. So that would mean both of these are light. Both of these are dark. Both of these are red, if that's the case. The yellow needs to extend out. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be done that way. But then this blue would not be able to go back here. So it cannot be 2 blues here around the third blue. Just the way the geometry works. Can it be this one then? Is kind of a good question, right? If it's there, this is red, this is light, and this is dark. This can never be yellow. This has to be blue. So this is blue. This is red. Again, the red can't be 2 doubles. I guess this could be blue going this way. Possibly 1, 2, 3, 4, 5, 6, 7, 8, 9. That's possible. Except that the yellow would be blocked. So no, that's not possible. So this can't be blue. This has to be, it can't be double red, because then that would be yellow here and green here. And these would both be 9. These would also both be 9, so that's not possible. So this is yellow. That would then force us to be yellow, yellow. This is orange, orange. This would be light. This would be dark. So this would be medium. This would be orange. This would be yellow. We have green here. This would be medium. So that's possible. Yeah. Okay, that seems kosher. Let's not pursue that one that much, because I think the other one will probably lead to a contradiction, maybe. So what happens if it's this one? If it's this... That means this is red. So this has to be red. This has to be blue. Well, not necessarily. Red could actually go that way. Well, what happens if red is this way? That means that's blue. This has to be yellow. We have 1, 2, 3, 4. One of these is red, one of these is blue. Or it can't be, well, could be blue. Well, it can't be both. We already showed that. That doesn't work. So this has to be yellow. Since this is yellow, either this is yellow or this is yellow. One of these is red, one of these is yellow here. So this is yellow, yellow, which makes this green, green, this medium, medium, this orange, orange. That seems fine. This would be 9. This would be 9. Obviously, this is green. Light would be this. So far this is okay. Medium. Dark. This would be 5, 6, and 8. To add, sorry, not 5, 6, and 8. 5, 7, and 8. To add up to 9, but this can't be 8, so this couldn't be 1. This is 2 and 4. That's fine. This would then have to be 9. This would be 9 and 9. This would be 9 and 9. So that's seems fine. 9 can't be here. 9 can't be here. 9's one of those two. That seems fine. Maybe I should check the other way. Maybe, yeah, that's the contradiction. This has to be yellow, that has to be orange, which makes that medium and that green. So say this was blue. This would then have to be orange. So we'd have this is orange, orange. This is yellow, yellow. Red is here. So this must be red, which makes this double yellow. This is double orange. This is green. So this would be yellow, blue. So that works, it seems like, also. Light. Medium. Orange. Dark. Okay. So this again would be 5, 7, or 8. This would have to be a 9. We'd have 9, 9 here, 9, 9 here, and 9, 9 here. So one of this would not be 9, so this would have to be 9. That seems kosher too. Two, 3, 4, 5, 6 could be 7, 8, 9. This can't be blue. You can't, you have to have 5 regions here. This is green, green. Therefore, this would have to be blue. And this would have to be its own region. One, two. So this would be blue, which would force this to be red. This to be light, this to be dark. The orange has to go out. So the orange has to go here. That means yellow has to go here. This can't be blue, so this would have to be yellow, but then we'd have a contradiction. Ah, and that's a contradiction there. We have to have 5 regions here, so this can't be blue. Right? We have to try to have a blue here. It must connect through here. This can never be blue, so this is a separate region. This has to be a separate region here. And because you can only have 5 because of the size of the line, then this has to be both blue. But then that forms a contradiction because then this can't be yellow anymore. 1, 2, 3, 4, 5, 6, 7, 8, 9. But it can't be blue either because it's divided by the boundaries. So that shows that this cannot go that way. So it has to go the other way. Okay, so that's the geometrical constraint. So this is blue. That must be orange, and it's 9. So this is 9 orange. The orange has to connect here. So this is orange. Yellow, green. This is light. This is dark. This is medium. Okay, so these are definitely borders. Border and border. This is red. So since this is 9, the orange, we know this is orange here. This is orange. This is light. No, it's medium. And this is green. But this can no longer be a single digit by itself. So this must be green and green. This must be orange and orange because this is a 9. So therefore this is red. That makes this blue, which makes this dark. And it makes this light. So this is all boundary here. This cannot be 3 digits. We showed that already. So this must be yellow. So this is yellow. That makes this also has to be yellow to be symmetrical. So yellow, yellow, this is yellow. That means this is a 9 here. This must be a singleton and a 9. This is medium gray. So this is boundary here, boundary here, boundary here, boundary here. This must be 9 and 9. This is, again, 6, not 6, 7, or 8, 5, 7, or 8 here. Cannot be 8, so this can't be 1. Blue could be here, and then this could be yellow and yellow. So this is 1, 2, 3, 4, 5, 6, 7. Obviously, this is red or yellow. This is also red or yellow. This is 9. This is 9. This is obviously red or yellow also. This is red or yellow. This is yellow or blue. Okay. So this must connect here, so this is orange. This must connect here, so it's medium. This is green. Okay. This is a single digit by itself. So this is 8. This has to be 2 digits. because we have a guaranteed one region here. It cannot be 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is guaranteed as two regions here. So this must be medium and light and light. That forces this to be blue. This to be red. So this is red here. That forces this to be blue, this to be light. This is dark and dark. So this can't be red, this is yellow. We have 1, 2, 3, 4, 5, 6, 7, 8. So one of these is yellow or red. This has to be orange. This has to be medium, and this is green. So we know that's a border. And here. Therefore, this is 8. Which means this can't be 8 here. This has to be 4. Which means this can't be 4 here. This adds up to 9. This can't be yellow and yellow. So this can't be, this adds up to 8. It's not 1, 2. It has to be a 3, 5 pair, which eliminates 3, 5 in the rest of that region. This has to be the same region because you can't have 6 regions adding up to that. So this must be yellow, which means this can't be yellow here. That's red. So since this is yellow, this is green, this is light, which makes this medium, which makes this dark, which makes this blue, and this orange. So those are the regions that we have. So those are the regions. This adds up to 8. So it's 1, 7, 2, 6, or 3, 5. This adds up to 9. So that means this cannot be 4 and 5. This could be 1 and 8, 2, 7, 3, 6, 6, 3, or 7, 2. This can't be 8, so this can't be 1. Therefore, this can't be 7. This can't be, to correspond, this can never be 5 and 3. This can never be 1 and 7. This is 1, 2, 4 as a triplet. This must add up to 9. So 1 and 2, 3, 4, 5, 6, 7, 8. 8 can't be here, so 1 can't be here. Okay. This adds up to 9. It cannot be 1 or 8. 2, 7, 3, 6, 4, 5. One of these is a 2 because it's either 1, 4, 1, 2, or 2, 4. So this can't be 2, which means this can't be 7. Where is the 9 in the blue region? Can't be here. Can't be along this line. Can't be here. So this must be a 9 here. Where is the 9 in the pink region? Cannot be here or here. So this must be 9 here. Okay. 8s. Remaining digits in the pink region are 3, 5, 6, and 7. Okay. One of these is a 3 or 5. One of these is a 3 or 5. That eliminates 3 or 5 in the rest of because this is a 3, 5 pair. This has to be 6, 7, and 8, actually. This can't be 8 because of the 8 in the row. This must add up to 9 also. So it's 1, 8, 2, 7, 3, 6, or 4, 5. 8 cannot be here, so this can't be 1 here. Huh. So we are guaranteed. Well, okay, never mind. 8 could be here. The remaining digits here are 3, 5, 6, 7, 8. Obviously, 8 cannot be here because of 8 in the row. So the problem we have now is how do we actually differentiate these values? Um, hmm. 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 Ah, in these regions, in the dark region and the medium gray regions, where are the 8s? The 8 cannot be here because of the 8 in the row. So this dark region must have an 8 in column in rows 1 and 2. This gray region has to have an 8 in rows 1 and 2. Therefore, there cannot be an 8 in the rest of that region in row 1 and 2. So this cannot be 8, which forces this to be an 8 here. So this can't be 8 here. This can't be 8 here. So this can't be 1 to add up to 9 with that. Well, there could be an 8 here. So one of these two digits is an 8 in row 5. I think we have all the 9s, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 8s are the ones that are most likely that we can actually do something with. Again, none of these can be 8 because of 8 is in the region, so one of these two is an 8. We also know, right, so 8 has to be one of these, 4, one of these. Okay, this cannot be 8 anymore because of the 8 in the column, so this can't be 1. So 8 cannot be here, 8 cannot be here. Where is the 8 in column 2? Can't be here, can't be here, can't be here because of the 8 in the regions, so this must be an 8 here, which means this can't be 8. Well, where's 8 in the blue region then? It has to be here. So this is 8, which means this can't be 8 here. Where's the 8 in column 6? Can't be in the yellow, can't be red, can't be pink, and this is a 9. So 8 has to be in the dark region, and it has to be here. So this cannot be 8. Where is the 8 in the medium gray region? Can't be here because 8 in column, nor here, 8 in column, 8 in column, 8 in column. This is a 9, so this must be 8, which forces this to be a 4. That eliminates 4 in the rest of the row and the rest of the column. This 4 eliminates 4 here, which means this can't be 5. This 4 eliminates 4 here, which means this can't be 5. So we should have all the 8s. This can't be 4. This becomes a 1-2 pair, which eliminates 1 and 2 in the rest of that region. So this cannot be 2. This is 4, which makes that a 2. Interesting. So this can no longer be 2 here. This can't be 2, so this can't be 7 here to add up to 9. We have a decent amount of 4s. This 4 means this can't be 4 here. Where's the 4 in this orange region? It must be one of these 3 digits. Okay. This can't be 4. So since this can't be 4, this can't be 5 here to add up to 9. Where is the 2 in this dark region? The 2 in the orange region has to be in columns 8 and 9. Guaranteed. Same with the blue region. Therefore, that eliminates 2 in the rest of columns 8 or 9. So 2 has to be one of these digits here in the dark region, which means this cannot be 2. This can't be 2, so this can't be 7. This can't be 2 because of the 2 in the column. Where is the 4 in the medium gray region? It has to be one of these 3 digits because it can't be any of these. So this can't be 4 anymore. This becomes a 1, 2, 1, 2 pair, which eliminates 1 and 2 in the rest of the light region. So this can't be 1 or 2. This is 4. That means this cannot be 4 here. So this can't be 4 and 5, adding up to 9. This can no longer be 4. So this can't be 5 to add up to 9 here. This 4 eliminates 4 here. Where's the 4 in this medium dark region? Sorry, medium gray region. It has to be here. This can't be 4, which means a 1, 2, 1, 2 pair in pink, which eliminates 1 and 2 in the rest of the pink region. So this is 4. So we should have a decent amount of 4s now. Where is the 4 in the green region? Can't be here because the 4 in the row can't be here. This can't be 4 and 5 because the 4 in the row can't be here because 4 in the row, so it must be one of these 2. So this can't be 4 here, which means this is a 4 here. Where's the 4 in the red region? Can't be here, can't be here, so this must be a 4 here, which means this can't be 4 here, which forces that to be 4. So we should have all the 4s now. 2s, we only have 1, so that's not helpful. We have 1, 2 pairs a lot. Oh, this is 4, so this must be 4 and 5 to add up to 9. That eliminates 5 here, 5 here. This 5, does it eliminate anything here? I don't really know. Where is the 5 in this orange region? Well, can't be here, so 5 must be one of these digits here. Well, 5 eliminates, that means this can't be 5 in column in the dark region here because of the 5 in the orange. This can't be 5, so one of these must be a 5 for the dark region, which means this can't be 5. So 5 is one of these 2. Where is 5 in the yellow region? It must be in rows 8 and 9. Where's 5 in the red region? It must be in rows 7, 8, or 9. And 5 has to be in 7, 8 in the orange region. That eliminates 5 here. 5 cannot be here. Where's the 5 in the green region? It has to be one of these two, which means this can't be 5. We have a 5 guaranteed in the light region in rows 4 and 5. We have a 5 guaranteed in the pink region in rows 4 and 5, which means there cannot be another 5 in that region. There can't be another 3 in that region in those rows too, because we have a guaranteed 3 in rows 4 and 5 in the pink and the light regions. So this can't be 3, this can't be 3, therefore this can't be 6. This can't be 5 anymore. That forces this to be a 5 here. What are the remaining cells in row 1? We have a guaranteed 3 and 5 in row 1 in the medium gray region. Therefore, 3 and 5 cannot appear anywhere else in the medium gray region. So this can't be 3, which means this can't be 6. This digit must match one of these 3. It can't be the 4. So this has to be a 1, 2, 6, 7 pair here. Therefore, both 1 and 2's cannot be here, because whatever 1, 2's here has to be one of these two digits here, and this is the other 1, 2. So this can't be 1, 2. This must be 3. It cannot be 4, 5. It has to be 6, 7 with it. So one of these is a 3. Therefore, one of these is a guaranteed 3 here. In the orange region, where's the 3? Obviously, it's in also column 8 or 9, which eliminates 3 in the rest of columns 8 or 9. So this can't be 3 here. Where's the 3 in the blue region? It can only be here. So this is 3, which means this can't be 3. This can't be 6. This again, so this can't be 3, because if this were 3, it would have to be in either the blue region or the red region. This is a 4, and this can't be 3 here. So this can't be 3. This is 6 or 7, which makes this 2 or 3. This 1 or 2 has to appear somewhere in the yellow region. It must be here. So this is 1 or 2. So we're going to mark this as A, and that must be A. This is B. So this also has to be, this could be 5. It could be 3. So this could be 3, 5, 6, 7, 8. 3, 5, 6, 7, 8. These can't be 8 because we already have 8 in the red region. Where is the 8 in row 8? It has to be here. So this is 8. Which means, where's the 5 possible now in the orange region? Can't be any of these because of the 5s the 2 5s that have to be in those rows. Can't be here because of the dark region has a 5. So this must be a 5 here, which means the remaining digits in the row 7 are 1, 3, 6, and 7. Okay. This can't be 5 because of 5 in the column. These add up to 8, so this cannot be 5 or 6. This is 1 or 2, which makes this the B 1 or 2. This 1, 2, 1, 2 pair eliminates 1 and 2 in the rest of the region, so this is 3. That makes this a 6, which makes this. So all the B's are 2's, and all the A's are 1's. This is a 6. 2 and 6 add up to 8. 3 and 6 add up to 9. That means this 6 must match here. So this is 6, which makes this 7. That means none of these are 7. We have a 3, 5, 6 triplet, which eliminates 3, 5, and 6 from the rest of the row. So this can't be 6. This is 2. That must make this 7 to add up to 9. This 2 eliminates 2 here, so it's 1 and 2. That eliminates 1 here. Where is the 1 in the red region? It must be here. So this is 1. 6 has to be one of these two, so 6 cannot be here. We have a 3, 5, 7 triplet, which eliminates 3, 5, and 7 in the rest of the row. That leaves this as 1 and 6, but this can't be 6, so this is 1. This can't be 6 or 7, so it's 3, which means this can't be 3 here. This orange, this is 1, which forces this to be 6. Since this is 6, this has to be 2 and 7, adding up to 9. This can't be 6 or 7. It can't be 1, so this is 3, which makes this 1. This can't be 3 or 6, so it's 7. This 2 eliminates 2 here, so it's 1. This makes that 2. This can't be 2, so this can't be 7 here. This 2 eliminates 2 here, so this must be 1. 2 cannot be here, here, or here, so where's 2 in the dark region? It must be here. So no 2, no 2. One of these digits is a 6. We have a, 3, 6 pair here. This can't be 3 because of 3 in the row. So this is 6, which makes this 3. This 6 eliminates 6 here, so it's 7, which means this can't be 7. This is 6, which has to be 3 and 6 adding up to 9. This 6 cannot be in the rest of row 1, so this must be 6, which makes this 7. 6 cannot be here or here. 7 can't be here or here. Therefore, this is a 3, 5 pair. That forces this to be a 6 here. This can't be 3 because of 3 in the column, so this is 5, which makes that 3, which makes this 5, which makes that 3. Therefore, neither of these could be 5. Neither of these could be 3. This can't be 5 anymore, so this is 7, which makes that 5. So this can no longer be 5. We have a 5, 7 pair in the yellow region, and this can't be 7 because of the 7 in the column, so this is 5, which makes that 7. That leaves this digit as a 2 in column 3. This 3 eliminates 3 here, so it's 6 and 3. That leaves this digit as a 1. And we have remaining digits in column 5 as 5 and 7. This can't be 7, so this must be 5, which makes this 7, which makes this 5. And therefore, this is a 6. And that's how you solve it. Pretty interesting use of the 90-degree symmetrical. That really limits things a lot geometrically. And then with the, because of that limitation, we knew that this couldn't be a cross, so it had to be a square. Because of this region sum line here. That's actually very interesting to have the region sum lines be across the little killer clues. That's why it's called the little region sum chaos construction, or CC. But pretty cool puzzle. Definitely hard, but yeah, not too bad. But I love chaos construction puzzles, so they're right up my alley. Anyways, I hope you enjoyed this solve today, and I'll see you next time on Frank Puzzles. Take care.